Thank you very much for the very well organization of the introduction. And yeah, so this paper is titled Quali-Mat Evaluating the Quality of Execution in Body Weight Exercises with a Pressure-Sensitive Sports Mat. It's a title, I know. So in the related work, there are lots of activity recognition in sports systems. On the left, there is one. On the left, there is one work from us before that we used a pressure-sensitive mat on the floor to distinguish different exercises. And you see also some, here is someone instrumented IMU on the gym weight rack to recognize the gym exercises from the same weight rack machine. In most of the sport activity recognition works, people are trying to recognize really drastically different exercises because the signal just looks so different from each other. You can visibly tell these are different exercises. But you know, in real sports training, quality is more important than quantity. Your execution, how well you execute, may just have a decisive factor in how well the muscle is being activated, how effective your outcome is, and this is still why people still have personal trainers. And also different variations of exercise may have different muscle activation. Even the same, if you go through roughly the same process, you will activate different parts of muscle. So, but in the relative work, none of the, well, only one did a quality of execution study here, talking about push-ups, right? None of the other related works that we found so far are looking into the quality of execution. So this is what we aim to do. It's not really about the hardware. This hardware is like published before, and you can also buy commercial sensing mats from companies like SensingTech. So hardware is quickly 120 by 64 pressure pixels on the ground with a 1.5 centimeter pitch at the 25 frames per second. And we have 12 participants, 3 sessions, each 9 exercise categories. Normally, the sports-related study will stop here. So, but we added 47 quality of execution variation. Just for one example, this is the 3 variations of sit-ups, like how high you reach at the terminal position. And our definition of these variations were decided together with the fitness trainers from a gym nearby. And we take the pressure mat data as a temporal sequence of spatial image arrays, and we evaluate several different deep learning models and compared with features and factory classifiers. The best performing one is also one of the smallest model, which is really important for sustainability. With the 3D convolution, that the convolution kernel directly takes care of the spatial and temporal information in the same kernel. And just for compare with the related work, it's trivial to detect these categories of exercises, 99% accuracy, our fine score. So what we want to look at is how can we distinguish these 47 variations, and this is confusion matrix of the 47 classes of variations. So it's still everything is mostly on the diagonal, which means we can somehow separate those variations. I'm just gonna go into different categories quickly. So first of all, these crunches that we saw, we can see that through our approach, we can differentiate different height of the terminal positions. And the side crunch is kind of sometimes classified as the normal crunch, which might be because the person was not really performing the side crunch as it's supposed to be. And this is the push-ups. So we only have 8 minutes, and this is like a 40-page paper. I don't know how to squeeze that in 8 minutes. So I want to show you the ones that did not work, or maybe the ones that was surprisingly working. So like this. Sorry. This is only back visible, so we only see just like the shadow of the back, but we can still distinguish leg raises, alternate cycling just from the temporal sequences of the exercises. And this is your back and arms are visible. So everything actually just looks like those shadows, but we can still distinguish the variations that the legs are moving in the air. And this is where it really struggles. You only see the feet, and the mat only see the feet. So the deep squats or shallow squats cannot really be well distinguished from each other. The only thing that can be distinguished is the tiptoe, because you like have some time that there's nothing, only the toes on the mat. And this is the lunges, and just lunges compared with the stepping. So the forward and backward are very clear separated. What we want to see is whether we can tell lunging from just stepping, because when you go down is when you activate the quads. And this bridging for the glute muscle. Yeah, so we can also distinguish it, especially the single-legged bridge can be well distinguished from the other one. And we also want to see whether it's a static hold or it's a going up and down the hip thrust. This is the one that really struggle, because all of the variations, so this is a side plank, and all of the variations are very far away from the floor, so that's where it really struggles. So in conclusion, so the plantar pressure could be a promising unobtrusive method in evaluating exercise of the quality of execution for daily activities for to use at home, because you can have a camera, but to have the angle, you need to really capture the full body. You need to put it far away from yourself. You need to have enough room, enough volume to place the camera. It performs well when this variation is closer to the pressure surface, and when it's far away, it struggles a bit. And another contribution is a lightweight machine learning model will really take care of the sustainability of the AI aspect. And the outlook of the study is, so quality of execution is very important in sport exercise. This is undebatable. But to design such studies really needs to take a lot of care. For example, I wish the hip thrust and the bridge, we could include different angles, or when you do the hip thrust that you rest on the floor, but not everyone can perform such activities. And even when you perform this, then you need to really have careful annotation from experts to see, okay, this second is the correct one, or this second is not the correct. So these require a lot of definition and care in the study design. And yeah, we also think it could be interesting to combine with other modalities to improve where it struggles. So thank you very much.
Thank you very much. So this is Sarah Bushnak from INSEE Lyon. Very, very interesting and clear presentation. Thank you. It's interesting to provide these measures, these metrics, but they look like low level. I mean, a final end user, it's difficult for him to try to interpret or to make use of them. I mean, it gives feedback, but how do you imagine some higher level metrics that would be easier to interpret by the end user?
Yeah, exactly. Thank you for your question. I think we need to work with the fitness trainers, because for different exercise, they have a different criteria. Like sometimes it's about the muscle activation, sometimes it's about the alternation between different exercises. It depends on the goal of the training. Sometimes you want to add more calorie expenditure inside, or sometimes you just want to add more activation inside. So maybe the calorie expenditure level or the activation might be interesting directions to make it more abstract and easy to understand as the end user. But thank you for the question.
All right, so let's thank speaker one more time.